in the last class, maybe some of you is already here. We talked about this problem. Is anyone here from the last class?
Yes, sir.
Yeah, in the last class, we saw that we are not getting correct answer. Okay, for the angular velocity of this rod. Okay, uh, can you recall that?
हाँ जी सर, वो याद आ रहा है.
Yeah, yeah. So I want to clarify that problem. Okay, so after that we will move further. So what was the problem? The main problem was, in the last equation, in the last problem, you can see that we are writing this equation. Okay, VC equal to V naught plus this, and for the VC for rod BC, we are writing this equation. Actually, to write these two equations, we must be very careful because this equation can only be written when the point where we are writing the velocity is not moving. You can see that here the point C for the rod BC is not moving. So the velocity of C with respect to this rod is good for this equation. Okay, but point C is moving for this rod. Okay, that's why we cannot write this equation. Okay, that's why we are getting incorrect answer. But when we are trying to solve by using curvilinear method, we are getting correct answer. So I will solve it again using the same rectangular coordinate system, but with the correct solution. Okay, so you can see that in the last class, we are writing this equation. Okay, you can see velocity of point P with respect to O, we can write this equation. Okay, so here R naught is what? Here R naught is what? It is the rate of change. It is the rate of change such that the distance between O and P is changing in this direction. Okay, that is R naught. And what is cos theta I plus sin theta j cap? That is nothing but the unit vector along this line. Okay, that's why I have written here R naught, that is a scalar quantity. So for that I have written R naught, and this one is what? Unit vector along this direction. Okay, so we have to, if we want if we want to know the correct solution, we have to use this equation. And in the previous discussion, we have seen that we are writing only this part, not this part. And if I want to write only this part, then we have to be very careful, because there may be a chance that the distance between O and P might be changing. Okay, and that was the case. That's why we were getting incorrect answer. Here you can see that if I write velocity of point C with respect to O, we will write this. Okay, R dot R dot R cap, and that is omega cross R. Okay, that is correct. Okay, and R dot here it is as it is R dot, and R cap is what? That is the unit vector along OC, and that unit vector is nothing but the what? Cos theta I cap plus sin theta j cap, and T here, T is the nothing but the angular velocity of rod OC. Okay, so for angular velocity we have written T k cap, and here R vector. Okay, so that is equation 1. Okay, here you can see that the R dot is not 0 because the distance between O and C is changing. But when you write the equation for the rod CB, you can see that the distance D is fixed. Okay, so for that R dot, I mean here it is D dot, that becomes 0. Okay, and it is the same as above, which can be right, which we can write here. Okay, so here you can see that point O is fixed. That's why VCO is nothing but equal to VC, and here point B is also fixed. That's why VCB can be written as VC. Now equate 1 and 2. Okay, when you equate 1 and 2, you will get this equation. Okay, from here you can directly compare I with J, I with I and J with J, or you can also do one thing. you can take dot product with I. Okay, when you take dot product with I, this will become 1, this will become 0, this will become 0, this will become 1. So here it will remain r dot cos theta and tr sin theta, and here this will become 0, and here you will get omega d sin beta. And when you take dot product with j, or you can compare with j, you will get this equation. Now you have two equations and two unknown. What are two unknowns? R dot and t. Okay, so when you want to find r dot and t, what will you do? We will first multiply this equation with cos theta. Okay, equation 3 with cos theta and equation 4 with sin theta. You will get r dot cos square theta, r dot sin square theta, and here that will become minus tr sin theta cos theta, and this will become tr sin theta cos theta. That will become 0 after adding, and here that will become what? Minus omega d sin beta cos beta sin theta. And when you take common with r dot, you will get here 1. Okay, because cos square theta plus sin square theta is equal to 1. When you take common minus omega theta, that will become this. Okay, and we already know that sin beta minus theta is equal to this, so we will get correct answer. Okay, now I want to find t. Okay, previously we are getting incorrect answer. Okay, that is omega, but the correct one was what? The correct one is this, that must be omega by 2. So what will you do? Here we already got r naught. Now I want to find t. So what will you do? Nothing. From this time I will cancel out this term. So for that, what will you do? You will multiply equation 3 with sin theta minus equation 4 with cos theta, and you will get the similar expression. Okay, so here you can find t. Okay, that is theta dot, and when you put the value of beta theta r equal to this, okay, then you will get what? Omega by 2. Okay, so here we were lagging. Okay, now I also want to find what? R double dot and theta double dot. That is not, if I want to find from this expression, that process will be very difficult. I mean, that process will be very lengthy. But if I want to determine R double dot, you can also do what? One more derivative. Okay, if you take I mean, if you differentiate this equation one more time, what will you get? You will get R double dot equal to what? Minus omega d minus omega dot. First you will apply what? Chain rule. Okay, so first omega will be differentiated, and here d is constant, then sine will be differentiated. So minus omega dot d sine beta minus theta. Okay, now minus omega dot d cos beta minus theta, and from the chain rule this will also be differentiated, so that will become beta dot minus theta dot. Here you can see that omega is constant. Okay, that this rod is rotating by a constant rate. Okay, so this part will become 0. Okay, so we will get omega naught. Okay, omega naught, not omega dot here, not dot, omega d only. So omega d, and we already got beta, that is 60, theta is 30, so cos 30 degree. And what is beta dot? What is beta dot? Beta dot is nothing but what? T, that is omega by 2. Okay, and what is theta dot? Theta dot, oh yeah, theta dot is omega, right? What is theta dot? Theta dot is, no, writing here incorrect. What is beta dot here? Yeah, beta dot.
Sir, omega is beta dot, sir.
Mm, what?
Is omega beta dot?
Yeah, no, beta dot I'm talking about. What is beta dot here? Yeah, beta dot is simply omega, right? Omega
हाँ sir.
minus, yeah, or theta dot is what? We are getting omega by
Omega by
2. Okay, so that will become omega by 2. That is omega square by 2 into d. A cos 30 means what? Root 3 by 2. So simply omega square d root 3 by 4. Okay, and in the second part, it was asking what is theta double dot. Theta double dot is nothing but 0, because that is rotating by constant rate. Okay, you can see that theta dot is simply what? Omega by 2. So if you differentiate it, it will become 0 simply. Okay.